What if one tree could feed a person for an entire year and we deliberately stopped planting it? Not because it failed, but because it worked too well. In 1793, Captain William Bligh completed what the British Admiralty called the most important botanical mission in naval history. He transported 2,126 breadfruit saplings from Tahiti to the Caribbean, not for science, not for curiosity, but because British plantation economists had calculated that a single breadfruit tree could feed an enslaved worker for an entire year at almost zero cost. One tree, one person, 1 year, no replanting, no annual labor, just harvest and eat. Within 50 years, breadfruit was feeding millions across the Caribbean and Pacific Islands. By 1850, agricultural reports described it as the tree that could end famine. Then something changed. By 1950, breadfruit had nearly vanished from global agriculture. Not because it stopped producing, not because people stopped eating it. It disappeared because a food source that grows on trees, requires no annual planting, and feeds people for free cannot compete in a food system built on corn, wheat, and dependence. This is the secret botanist. We don't explore plants. We exhume them. Today we are opening the file on Artocarpus altilis, the tree that produces more calories per acre than almost any crop on Earth, costs nothing to maintain, and was systematically erased from agriculture because abundance without labor is incompatible with commodity markets. The suppression of breadfruit was not a conspiracy. It was an economic recalculation. When staple crops can be sold annually, a perennial tree that feeds people for 50 years without replanting becomes a problem to solve, not a solution to hunger. And the botanical evidence is still fruiting in tropical regions, waiting for anyone willing to remember what we deliberately forgot. Breadfruit is not bread, and it is not fruit in the way most people understand the term. It is a starchy staple, closer to potato, cassava, or taro than to apple or orange. The fruit is a composite structure, a fused mass of flowers that swells into a single edible unit weighing between 2 and 10 pounds. One breadfruit contains approximately 600 to 1,200 calories, depending on size and variety. A mature tree produces 50 to 150 fruits per season. Some trees produce 2 seasons per year. Do the mathematics. A single breadfruit tree can yield 150 fruits annually. That is 90,000 to 180,000 calories per tree per year. For comparison, 1 acre of potatoes yields approximately 15 million calories. 1 acre can support roughly 100 breadfruit trees at optimal spacing. That is 9 to 18 million calories per acre, comparable to or exceeding potato yields. Except breadfruit trees live for 50 to 80 years without replanting, require no tillage, and need no annual inputs. But the caloric density is only part of the story. Breadfruit is nutritionally complex in ways that challenge the industrial definition of staple crop. It contains significant protein for a starch source, 5% by weight when cooked, comparable to rice. It provides vitamin C, potassium, magnesium, and dietary fiber. It is gluten-free, easily digestible, and can be consumed at multiple stages of ripeness, each offering different culinary applications. By the 1780s, British sugar plantations in Jamaica and other Caribbean islands were operating at maximum expansion. Enslaved laborers required food, and importing provisions from Europe or North America was expensive and logistically complex. Plantation owners wanted a cheap, reliable food source that required minimal land and labor to maintain, land and labor that could otherwise be dedicated to sugar production. Breadfruit, as described by Banks, was the perfect solution, a tree that fed people for decades without replanting, without cultivation, without cost. In 1787, the Admiralty commissioned William Bligh to sail to Tahiti, collect breadfruit saplings, and transplant them to the Caribbean. Bligh departed on HMS Bounty with orders to convert the ship into a floating greenhouse. The mission failed when the crew mutinied in 1789, but Bligh survived and convinced the Admiralty to fund a second attempt. In 1791, he sailed again on HMS Providence, and in 1793, he successfully delivered 2,126 breadfruit plants to Jamaica and St. Vincent. The trees thrived. Within a decade, breadfruit was fruiting across the Caribbean. By 1810, it was a common food source on slave plantations, exactly as the British had planned. By 1850, breadfruit had spread throughout the tropical Americas and was being cultivated in parts of Africa and Asia. Agricultural reports from the mid-1800s describe breadfruit as the tree that could end famine and the most productive food plant known to tropical agriculture. Then, gradually, breadfruit disappeared from mainstream agriculture. Not suddenly, not through blight or disease. It faded over decades as global food systems industrialized and commodity crops became the standard. By 1950, breadfruit was marginalized, grown in backyard gardens and smallholder farms, but absent from commercial agriculture and international trade. By 2000, it was nearly forgotten outside the Pacific Islands and scattered tropical regions where tradition kept it alive. So the question becomes unavoidable. Why? If breadfruit is calorically dense, nutritionally complete, perennial, low maintenance, and proven across centuries of cultivation, why did it vanish from global agriculture? The answer is not environmental. It is economic. Breadfruit cannot be commodified in the way industrial agriculture demands. Unripe breadfruit is firm and starchy, prepared like potato. Ripe breadfruit is sweet and soft, eaten fresh or baked. The tree itself is a botanical marvel of self-sufficiency. Breadfruit grows rapidly, reaching fruit-bearing maturity in 3 to 5 years, depending on variety and conditions. It thrives in tropical and subtropical climates with minimal maintenance. The tree is deep-rooted, drought-tolerant once established, and remarkably pest-resistant compared to annual crops. It does not require fertilizer if planted in reasonably fertile soil. It does not demand irrigation beyond what rainfall provides in most tropical regions. It simply grows, fruits, and continues producing for half a century or more. This is not speculative. This is documented agricultural history. Pacific Islander societies built entire food systems around breadfruit for over 3,000 years. In pre-contact Hawaii, breadfruit groves were considered wealth, permanent assets passed through generations. In Polynesia, a family's breadfruit trees were counted like livestock. 20 trees could sustain a household indefinitely. The tree was not supplemental. It was foundational. The British encountered breadfruit during Captain James Cook's voyages to the Pacific in the 1760s and 1770s. Cook's botanist, Joseph Banks, observed breadfruit cultivation in Tahiti and recognized its implications immediately. He wrote in his journals that breadfruit surpasses all other vegetables in usefulness and calculated that 3 trees could sustain 1 person year-round. Banks reported these findings to the British Admiralty and the Royal Society, arguing that breadfruit could solve a specific problem the British Empire faced in the Caribbean. First, breadfruit does not ship well. The fruit is delicate, with a short post-harvest shelf life of 2 to 5 days at room temperature. It bruises easily during transport. It cannot survive the global supply chains that move wheat, corn, and rice across continents in controlled environments. For breadfruit to be consumed fresh, it must be grown near the population it feeds. This makes it incompatible with centralized industrial food systems where production is concentrated in specific regions and distributed globally. Second, breadfruit does not store easily in its fresh form. Unlike grains, which can be stored for months or years with minimal processing, fresh breadfruit must be consumed quickly or preserved through drying, fermenting, or freezing. Traditional Pacific Islander societies developed preservation techniques. Fermented breadfruit paste called masi in Fiji or ma in Hawaii could be stored underground for years. But these methods require knowledge and labor that industrial food systems eliminated in favor of shelf-stable processed products. Third, and most critically, breadfruit is perennial. It does not fit the annual planting cycle that dominates global agriculture. Farmers cannot purchase breadfruit seeds every spring. Seed companies cannot sell annual inputs. Equipment manufacturers cannot sell tillage machinery. Fertilizer companies cannot sell synthetic nitrogen for a tree that fixes its own fertility through deep roots and leaf litter. The entire industrial agriculture supply chain, seeds, chemicals, equipment, credit, insurance, is structured around annual crops. Breadfruit exists outside that system. A breadfruit tree planted today will produce for 50 years without replanting. That is 50 years of food without purchasing seeds. 50 years without buying fertilizer. 50 years without dependence on agricultural supply chains. From a humanitarian perspective, this is ideal. From a market perspective, this is unsellable. You cannot build a profitable industry around a product people purchase once and use for half a century. By the early 1900s, global food systems were consolidating around commodity grains: wheat, corn, rice. These crops had multiple advantages for industrialization. They could be mechanically harvested. They could be stored indefinitely. They could be transported globally. They could be processed into hundreds of products. And most importantly, they required annual replanting, creating perpetual demand for seeds, fertilizers, pesticides, and equipment. Governments supported this transition through subsidies, research funding, and infrastructure investment. Universities focused agricultural research on improving grain yields. Extension services taught farmers to grow commodity crops. International development programs promoted wheat and rice as solutions to hunger, even in tropical regions where breadfruit was ecologically better suited. The entire institutional framework of modern agriculture was designed to favor annual grains over perennial staples. Breadfruit was not banned. It was simply ignored. No research funding, no breeding programs, no infrastructure development, no market promotion. While corn and wheat received billions in subsidies and research investment, breadfruit remained a subsistence crop, a term that in agricultural economics means not worth commercializing. By the 1970s, breadfruit had been so thoroughly marginalized that most people in temperate regions had never heard of it. But the tree did not disappear. It retreated to the margins: backyard gardens in the Caribbean, smallholder farms in the Pacific, community grows in parts of Africa and Southeast Asia. In these places, people who remembered or never forgot continued planting breadfruit, harvesting it, eating it, and passing trees to the next generation. The knowledge survived in the places industrial agriculture had not yet fully displaced traditional food systems. And now, the botanical evidence is forcing a reconsideration. Climate change is destabilizing grain production. Wheat and corn are increasingly vulnerable to heat stress, drought, and extreme weather events. Staple crop yields are declining in many regions. At the same time, global population continues rising and pressure on agricultural land intensifies. Suddenly, a perennial tree that produces massive caloric yields without annual inputs looks less like an obsolete relic and more like an answer. In 2003, the National Tropical Botanical Garden in Hawaii launched the Breadfruit Institute to research, promote, and distribute breadfruit globally. They have since distributed over 100,000 trees to tropical regions worldwide, focusing on areas facing food insecurity. In 2010, research published in the journal Acta Horticulturae confirmed that breadfruit flour, made by drying and milling the fruit, has a shelf life of over 1 year and can replace wheat flour in most baking applications. This solved the storage and transport problem that had limited breadfruit's commercial viability. In 2016, a study by the University of British Columbia calculated that breadfruit cultivation could significantly reduce food insecurity in tropical regions if integrated into agricultural systems. The study noted that breadfruit requires 10 times less water than rice and produces more calories per acre than cassava. In 2020, the Food and Agriculture Organization of the United Nations officially recognized breadfruit as an underutilized crop with significant potential for food security. These are not fringe sources. These are mainstream agricultural institutions acknowledging what Pacific Islanders have known for 3,000 years. Today, you can grow breadfruit if you live in USDA hardiness zones 9 through 11, southern Florida, southern California, Hawaii, parts of Texas. The trees are available through specialty nurseries and botanical gardens. Breadfruit Institute distributes trees for free or at minimal cost to farmers in tropical regions. The cultivar Myaphylla is particularly productive and widely adapted. Trees begin producing in 3 to 5 years and can yield 50 to 200 fruits annually, depending on care and climate. Breadfruit is prepared by boiling, roasting, baking, or frying. Unripe breadfruit can be sliced thin and fried like potato chips. Ripe breadfruit can be mashed and baked like sweet potato. Breadfruit flour is gluten-free and can be used in bread, pancakes, and pasta. The fruit can be fermented into traditional preserved pastes or frozen for long-term storage. It is culinarily versatile in ways that contradict the limited-use narrative that justified its marginalization. The cost of establishing a breadfruit grove is the price of saplings and the labor of planting, typically $20 to $50 per tree, depending on source and region. After establishment, the ongoing cost is nearly zero. No annual seeds, no fertilizer, minimal pest management, just harvest. For a household in a tropical region, 10 breadfruit trees can provide a significant portion of yearly caloric needs indefinitely. For a community, a breadfruit grove becomes permanent food security infrastructure. The disappearance of breadfruit from global agriculture was not a failure of the tree. It was a structural incompatibility between perennial abundance and economic systems that require scarcity and dependence to function. A crop that feeds people for 50 years without replanting does not generate recurring revenue. It does not require chemical inputs. It does not depend on seed companies or equipment manufacturers. It is, in economic terms, valueless, not because it does not produce value, but because it produces value outside the market. You have a choice. You can accept the industrial food system's answer to hunger, annual grains requiring continuous inputs, vulnerable to climate disruption, dependent on global supply chains. Or you can plant a tree that produces food for half a century and ask why we were told to forget it existed. The method works. The tree grows. The only question is whether we are willing to rebuild food systems around abundance instead of scarcity. Captain Bligh transported breadfruit to the Caribbean to feed enslaved people as cheaply as possible. The tree succeeded at that task so well that it exposed the central problem industrial agriculture refuses to solve. Food abundance without dependence undermines the markets built on selling food. The British Empire planted breadfruit to reduce costs. A century later, global agriculture abandoned it for the same reason. Free food does not scale in economies built on selling food. If this file changed how you see the fruit trees no one plants anymore, subscribe to The Secret Botanist. We are excavating the crops they replaced with commodities. The next excavation reveals which grain was removed from global markets in 1961 because it grew too easily in too many climates. Some crops were abandoned because they failed. Some were abandoned because they succeeded without creating dependence. The botanical evidence does not lie. The breadfruit trees are still fruiting. What you choose to plant determines which system you feed.